Hi everyone, welcome to Unit 29 of online course on probability distributions. In previous sessions, we have discussed geometric distribution, negative binomial distribution and hypergeometric distributions. And we derived mean, variance and some other properties of these distributions. And now in the succeeding sessions, we are going to find or going to establish some applications of geometric distribution, negative binomial distribution and hypergeometric distribution in different fields by giving some numerical examples. So, let us consider some examples in the field of geometric distribution in this session. So, consider, suppose you have a problem like this. Suppose we perform the Bernoulli trials until a success is obtained, and let us define x as the number of trials required for getting a success. And the problem is find the probability distribution of x and also obtain mean, variance and moment generative function of that random variable. So, the question here, we are defining a random variable x, that is the number of trials required for getting a success. See, in the case of geometric distribution, we have defined already. Suppose the geometric distribution we have defined. So, Bernoulli trials are performed until a success is obtained. So, we are performing Bernoulli trials with a probability of success p until a success is obtained, and we have defined x as the number of failures preceding the first success. So, this was the definition we have given while defining geometric distribution. So, if it is x number of failures preceding first success, means these are the possible values of the random variable x. And corresponding probability mass function probability values x is equal to this k, it is if it is this one p, this is qp and this is q square p, etc. So, that is in the case of this random variable, we have the value q power x into p, where x is equal to 0, 1, 2, etc. This was the distribution we have defined earlier with respect to geometric random variable. And now the question here is, it is actually the problem here is something different. Suppose we are performing Bernoulli trials until a success is obtained, and let us define x as the number of trials required for getting success. Number of trials required for getting a success. So, that is x as the number of trials required for a success. Okay. So, x it may be 1, 2, 3 values. These are the possible values of that random variable. And corresponding probability values, if it is the number of trials required for a success. So, first trial itself is a p, the success. So, it is the probability value is p. So, it is qp and this is q square p etc. So, generally our f of x is q power x minus 1 into p, where x is equal to 1, 2, 3, etc. So, this is the probability mass function of geometric random variable if the random variable is defined in another way, that is the number of trials required for a success. Earlier we have the random variable x, number of failures preceding the first success. But here we have the random variable x, that is the number of trials required for a success. So, instead of suppose we have make this as y, suppose we have number of trials required for a success, then so suppose we make that as y, and earlier we have x is the number of failures preceding the first success. Then we know y is nothing but x plus 1. So, if y is the number of trials required for a success is the definition, and x is the definition that we have already given in previous session for the geometric random variable as number of failures preceding the first success, then y is nothing but x plus 1. So, probability value of y can be obtained. This probability value of y is equal to probability value of x plus 1 is equal to y, or that is probability value of x plus 1 is equal to y means probability value of x is equal to y minus 1. And earlier we have the probability value of x is equal to k or x is equal to x is q power x into p. So, this is q power y minus 1 into p. And what are the values of y? Y is equal to 1, 2, 3, etc. Y is equal to x plus 1, and x have the values from 0, 1, 2, 3, etc. So, y can have either 1, 2, 3, etc. values. So, this is by transforming the variable y is equal to x plus 1, we have the probability mass function of the random variable y, where y is defined as the number of trials required for a success. So, this is another way of describing the geometric distribution. We can describe the geometric distribution in two ways. Either if you are defining the random variable as the number of failures preceding first success, that is one way, or you can define the random variable as number of trials required for a success. So, in both cases we call it as geometric distribution. So, the question here is to find the mean and variance of this random variable. So, how do you find the mean and variance? So, suppose x is a random variable having the f of x as q power x minus 1 p, where x is equal to 1, 2, 3, etc., where x is the number of trials required for getting a success. Okay. So, suppose we are defining x as the number of trials required for getting a success, then f of x is equal to q power x minus 1 into p, where x is equal to 1, 2, 3, etc., and p plus q is equal to 1. Now the problem is to find the mean of this particular random variable, mean of this random variable, expectation of x, and that is sigma over x, x into f of x, and simplifying this is sigma over x equal to 1 to infinity x into q power x minus 1 into p. So simplifying, that is equal to when x is equal to 1, this p is taken outside of this expression. So 1 into q power 0, so 1, 2q plus 3q square plus etc. And that is a non-series, infinite series for us. So p into this is 1 minus q all power minus 2, or that is p divided by 1 minus q square. 1 minus q square means actually it is p square, or that is 1 by p. So for this particular random variable f of x having the mass probability mass function q power x minus 1 into p, the mean is equal to it's 1 by p. But in the case of the geometric distribution, that is defined in another way, that is the number of failures preceding the first success, our mean is equal to q divided by p, that we established in that session. But if we are defining x as the number of trials required for getting a success, mean is equal to 1 by p. And how do you find the variance? So to find the variance, we have to find expectation of x square. And here also we substitute x is equal to 1 to infinity x square into q power x minus 1 into p. So that is our expectation of x square. And that can be easily obtained because when you are expanding this the series, this is actually equal to p into, this is x is equal to 1 means, so you have 1 plus 2, that is 4 q plus then 2, 3 square 9 q square plus etc. So that is p into 1 plus 4q plus 9q square plus etc. And that is equal to, this is equal to, we can write this p into 1 plus 3q plus 6q square plus etc. in one term, and plus the remaining terms. Remaining terms, here it is, actually we have 4q, but we have taken only 3q, so q, and 9q square we have taken 6q square only, so we have 3q square plus etc. Okay. And that is again equal to 1 p into, and if you want, and this is a non-series for us, so 1 minus q all power minus 3 is the value, plus here also you take q outside, so this 1 plus 3q plus next term will be 6q square etc. And that is simplified, you will get it as p into 1 minus q all power minus 3, or we can write it as p power minus 3 plus q into, this is also, we know it is 1 minus q all power minus 3, again that is p divided by p cubed, that form, plus p q divided by p cubed. Okay. That is p into p power 3, or that is 1, that is equal to p divided by p cubed, that is 1 by p square plus this is q divided by p cubed and this p. So, q divided by p square. So, using the non-infinite series, that is 1 minus q all power minus 3, this is simple to establish for this particular random variable, easy to establish expectation of x square, that is 1 by p square plus q divided by p square. And if it is 1 by the expectation of x square we obtained as, expectation of x square is obtained as 1 by p square plus q divided by p square. And earlier we have the expectation of x we obtained as 1 by p. Hence, what is the variance of x? Variance of x is expectation of x square minus expectation of x the whole square. Substituting the values, 1 by p square plus q divided by p square minus expectation of x the whole square, that is 1 by p the whole square. And cancelling the common terms, that is cancelling 1 by p square and minus 1 by p square, it is q divided by p square. So, for a random variable, geometric random variable of that type, variance is equal to q divided by p square. See, mean is equal to 1 by p and variance is equal to q by p square. So, these are the two quantities we established for that particular random variable f of x, that is defined as the geometric random variable having the probability mass function f of x is equal to q power x minus 1 into p, where x have the values 1, 2, 3, etc. And now you find the moment generative function also. So, to find the moment generative function, mxt, that is equal to expectation of e power t x. So, for this particular random variable, this is equal to sigma over x is equal to 1 to infinity e power t x into the probability mass function, that is q power x minus 1 into p, and that is equal to p into sigma over x is equal to 1 to infinity. You can have this value e power tx into p, q power x minus 1. And expanding, you have p into, when x is equal to 1, it is e power t, and x is equal to, it is e power 2t q plus e power 3t into q square plus etc. Or that is equal to p into e power t 1 plus e power 2t, e power t, e power t into q plus e power 2 e power t into q the whole square plus etc. That way you can write. Or this is p into e power t 1 minus e power t q all power minus 1, or that is p e power t divided by 1 minus q e power t. So, the moment generative function is equal to p into e power t divided by 1 minus q e power t, provided q e power t less than 1. So, these are the these are the values, that is mean, variance and moment generative function of the geometric random variable if we are having the definition for random variable x as the number of trials required for getting a success. So, these are the matters we have already established. If x is a geometric random variable with a probability mass function, f of x is equal to q power x minus 1 p, where x is equal to 1, 2, 3, etc., p plus q is equal to 1, then mean and variance of the distribution are given by expectation of x is equal to 1 divided by p, variance of x is equal to q divided by p square, and mxt is equal to p e power t divided by 1 minus q e power t. Now, you are addressing some numerical problems, and for that problem we are getting the answer based on the concept of geometric distribution. Here the problem here is a representative from a marketing division randomly selects people on a street in a city until he or she finds a person who owns an electrical vehicle. So, the problem is what? Actually, it is a marketing survey, and a representative from marketing division randomly selecting people on a street in a city until he finds a person who owns an electrical vehicle. So, here until we are performing that experiment until a success is obtained. What is a success here? Identifying a person who owns an electrical vehicle. And let p is equal to 0.08 be the probability that he succeeds in finding such a person. That is probability of getting an success, or that is probability of getting probability of identifying a person who owns an electrical vehicle, p is equal to 0.08, that is given to you. And if it is the question, let x denote the number of people he selects until he finds his first success. What is the probability mass function of x? So, this is a typical example of the geometric distribution. Here what we are doing here, actually the problem here is, here x denote the number of people he selects until number of people selected. Until a success is obtained. What is the meaning of success here? A person having electrical vehicle, and you are given p is equal to 0.08. Okay, 0.08. So, what is the probability that this x is equal to x? That is our probability distribution, probability mass function. And here it is p is equal to 0.08 means what? Q, it is 0.92. So, what is our probability mass function of this? 0.92 power x minus 1 into 0.08. Because we have the f of x value, it is q power x minus 1, q power x minus 1 into p. This is the probability mass function if we define x is the number of trials required to get a success. Here x is what? Number of people selected, that is similar to the number of trials required for a success. So, f of x is our q power x minus 1 into p. So, our q is equal to 0.92 and p is equal to 0.08. So, what are the possible values of x? X is equal to 1, 2, 3, etc. So, this is the probability mass function of that particular random variable. So, the question we have, what is the probability mass function of x? And find the mean and variance of x. You know what is the mean and variance? the mean and variance is equal to mean is equal to, for that particular random variable, we have already derived the mean is equal to 1 by p and variance is equal to q divided by p square, and 1 by p, that is 1 divided by 0.08, and this is a 0.92 divided by 0.08 the whole square. So these are the values of mean and variance of that particular random variable. So this is an example that is identifying a person who owns an electrical vehicle, that is our success in this case, and as a marketing survey is conducted until a success is obtained. So what is the mean and what is the variance and what is the probability mass function of that particular random variable, that are given by the concept of the geometric distribution. So the probability distribution function is, this is the value, probability of x is equal to x is equal to 0.92 x power x minus 1, 0.08 x is, where x is equal to 1, 2, 3, etc. And the mean and variance I have already given, that is obtained by 1 divided by p in the case of mean, and variance is equal to q divided by p square. You substitute q and p there, you will get the mean and variance. So similar to this problem, another question. Suppose you have a problem like this. Each ticket in a certain lottery has a 20% chance to be a prize winning ticket. And let x be the number of tickets that need to be purchased for a first prize. What is the distribution of x? So again, you go through that problem. Each ticket in a certain lottery has a 20% chance to be a prize winning ticket. So what is given actually? 20% chance to be a prize winning ticket. Suppose P is taken as the probability of success, that is prize winning ticket, that is equal to 20% chance, 20 divided by 100. And so we have the q, naturally we have the q value 80 divided by 100. So you are given P and Q. And what is given to you? X, the random variable related with the random variable x. It is a number of tickets that need to be purchased for a first prize. Okay. So number of tickets to be purchased, number of tickets to be purchased for a success. So x is similar to what? X is the number of trials required for a success. So here the x is number of tickets to be purchased for a success, and for that particular case we have the f of x value, it is equal to q power x minus 1 into p, where x is equal to 1, 2, 3, etc. Or this is our probability mass function, x is equal to x, or you represent f of x. So that is, what is the answer? The answer is probability of x is equal to x. It is equal to 0.80 power x minus 1 into 0.820, where x is equal to 1, 2, 3. Another example, if the probability that a target is destroyed on any one shot is 0.30, what is the probability that it would be destroyed in the 6th attempt? So this is also a question usually asked in some practical situations, practical problems. We have to address this type of questions. If the probability that a target is destroyed on any one shot is 0.30. So what is given actually? That is, a target is destroyed, that is our success. And let P be the probability of getting success, and that is given as 0.30. Okay. So a target is destroyed on any one shot is given as, the probability that a target is destroyed on any one shot is given as 0.30. So P is equal to 0.30. Of course, Q is equal to 0.70. And what is the probability that it would be destroyed in the sixth attempt? See, for that we just define what is x. X is number of trials required for a success. Here the success means target is destroyed. See, so this is the way we are defining the random variable. X is the number of trials required for a success, and here the success is the target is destroyed. So our question is the target is destroyed in the sixth attempt. So our problem is to find number of trials required is 6. Okay. So before that, what is the general expression? General expression probability of x is equal to x, our geometric probability mass function, we have this value. So probability mass function of that particular random variable is q power x minus 1 into p, where x is equal to 1, 2, 3. And the problem now reduces to what is the probability of x is equal to 6. That is q power 5 into p, or that is 0.70 power 5 into 0.30. So this is the value of probability of x is equal to 6, or this is the probability that the target is destroyed in the sixth attempt if you are given that the probability of destroying a target is 0.30. So this is also an application of the probability geometry distribution. So we have probability of x is equal to 6 is 0.70 power 5 into 0.30. So a certain basketball player has 70% chance of making a free throw, and assume all free throws are independent. What is the probability that he makes the free throw on his third attempt? Also find the probability if he takes 3 or 4 trials to make the free throw. So two part of the question. What is the probability that he makes the free throw on his third attempt? So first of all, you identify the random variable. What is the random variable? Suppose you are defining x as the number of throws required for a basketball player in order to make that throw correct, make that throw fruitful. So what is the probability distribution of that random variable? Suppose you have number of free throws. Number of free throws required for a basketball player in order to make the attempt fruitful. So what is the probability that he makes the free throw on his third attempt? Okay. So what is the probability value given? 70% chance. So P is equal to 0.70 and Q is equal to 0.30. What is the probability that he makes the throw on the third attempt? So that means probability of x is equal to 3. Earlier we have probability of x is equal to x is q power x minus 1 into p is our theoretical value. So this is q power 2p, or that is 0.30 the odd power 2 into 0.70. Simplifying that expression, you will get the answer. And the question is, again, also find the probability that if it takes 3 or 4 tries to make the free throw. So 3 or 4 times, 3 or 4. What is the probability? So that is obtained by this probability of x is equal to 3 plus probability of x is equal to 4, and that is equal to Probability of x is equal to 3 is 0.30 the whole square into 0.70 plus probability of x is equal to 4, that is 0.30 power 3 into 0.70. So, simplifying that, you will get the answer. So, these are some simple examples where we can apply the geometric distribution to get probability values. So, here also the question is similar to the earlier one. Assume that the probability of a defective component is 0.02. Components are randomly selected. Find the probability that the first defective is caused by the 7th component test. How many components do you expect to test until one is found to be defective? So, question, assume that the probability of a defective component is 0.02 and components are randomly selected. Components are randomly selected. Find the probability that first defective is caused by the 7th component test. So, 7th component tested means on the 7th trial we have the defective part of the, we have identified the defective component. Okay. So, what is the probability value here? Probability of x is equal to, here you have to give the P is given as 0.02 and Q is equal to 0.98 and probability of x is equal to 6 you have to find, because we have the we have to 7th. Okay. Seventh test we have the defective component is obtained. So, x is equal to 7. So, that means we have the probability of x is equal to x, generally we have q power x minus 1 into p. So, here it is q is 0.98 power 6 0.02. So, that is the value of that particular problem, probability value, when we are identifying the computer components and verify whether it is defective or not, and what is the probability that on the 7th trial we have identified the computer component is defective. And again, if it is, what is the mean of that? Mean is equal to what? Mean, we know mean is equal to 1 divided by p, that is 1 divided by 0.02 or that is 50. So, mean is the value, that is mean of number of trials required to identify the defective, to get a defective part of the component. Okay. Let me wind up this session here and thank you for listening, and we will discuss further examples related with geometric, negative binomial and hypergeometric distribution in succeeding sessions. Thank you.